go. So today's tutorial, we are looking at scale. We're going to be focusing on level 1 today, with hopefully moving and progressing on to level 2 together next week. So level 1 today mainly. Let's move on to today's tutorial. So the aim of today is to understand how to read a given scale, and the objective, by the end of the session, you'll be able to use the scale given to calculate plan and real life measurements. So it's a bit of an introduction on scale first. Why and when do we use scale? We use scale in maps, drawings and plans. They all use scale. Maps, drawings, plans and models cannot be the same size as the real life thing they represent. So we use a scale to allow us to calculate the real life measurements. And when we talk about scale, it's the most common thing I can think of to describe it is when you have something like a model car. And remember, they always come with this scale of 1 to 10 or 1 to 60. It's because it's literally been scaled. Every single part of it has been scaled up and down by exactly the same amount. And that's what we use a scale for, mainly for accuracy. So scale drawings are everywhere. They're on maps, footprints of houses, on scale drawings themselves, even things like vehicle design. A scale drawing allows us to draw large objects on a smaller scale while keeping them accurate. All scale drawings must have a scale written on them, and scales are usually expressed as ratios. So when we say ratio, we mean that colon in the middle, like this. At level 2, all of your ratio would probably be represented like this. At level 1, you might actually have them represented with an equal sign in between. So it could be 1 centimetre to 100 centimetres. At level 1, you might actually get 1 centimetre is equal to 100 centimetres. It means the same thing. It's just described, that's the difference between the two levels. At level 1 and 2 you could get this, but you can get this one at level 1. But it means exactly the same thing. So the ratio 1 centimetre to 100 centimetre means that for every 1 centimetre on the scale drawing, the length will be 100 centimetres in real life. So this is one thing we're going to go through today. I'm going to repeat myself quite a lot because it's a way to obviously help you to understand further. When it's written like this, whether it's with the colon or the equal sign, one side is always the plan side and one side is always the real life measurement. So it seems pretty obvious on most times, most occasions. So the 1 centimetre is the plan because it's the smaller size. And this side, the 100 centimetres, is real life. So 1 centimetre on whichever plan this is for is equal to 100 centimetres in real life. Okay, we've got quite a few examples to go through together. So here's another one. So a scale of 1 centimetre equals 2 metres means for every 1 centimetre equals 2 metres. Every 1 centimetre is equal to 2 metres in real life. And it doesn't tell you which side is which. It doesn't say this is real life and this is the plan. But your plan's not going to be 2 metres wide, your map, your drawing, compared to 1 centimetre in real life. So the smaller side is often the plan side. So this is the plan measurements, and this is the real life. So whichever plan this is, every 1 centimetre is equal to 2 metres in real life. Is everybody okay so far? Yeah? Fabulous. Thank you very much. So this is where I'm going to show you how I work out scale. I've shown this to quite a few people before, and it's a bit like Marmite. It either works for you or it doesn't, or you might just need to think about it a little bit more to get your head around it. But if you can use this method with scale, you can actually scale up anything. You can convert from pounds to pence to you can scale up and down with your maps and your drawings. So I'll show you it first and we'll see what you think to it. So if a scale given as 1 to 500. So with scale, we don't always get a measurement, a unit. So this could mean 1 centimetre to 500 centimetres. It could mean 1 metre to 500 metres. You will know though from the question as to what we're working in. So the first one is, what real life distance would be represented by 4 centimetres? Okay, so this is our plan side. This is real life. So every one of whatever the distance is equal to 500 of them in real life. So what real life distance would be represented by 4 centimetres? So what I do is pop in what I know. So I know that the distance on the plan is 4 centimetres. So I'll put the 4 here. Okay, I then need to figure out how much that is worth in real life. So to do that, I look at how much we've scaled up by. So on the plan, we've gone from 1 to 4. So we've increased the plan size by 4 times. Okay. So what I'm going to do is increase the real life size by exactly the same amount. By 4. So that would give me a real life measurement. This was centimetres. A real life measurement of 2000 centimetres. Is that okay? Shall I do another one? So the next one is, what real life distance would be represented by 2 metres? Okay, so we've got 2 metres this time. On the plan, what's the real life distance? So this was our scale. We've increased the scale this time by 2 times as much. We've gone from 1 to 2, so it's increased 2 times as much. So we multiply it by 2. So because we've multiplied this side by 2, we also multiply this side by 2 to give us 1,000 metres. And it's metres because the plan was given in metres. What does everybody think to that method? I will do another one. I'll write the scale out again. We'll start again here. So if the scale is 1 to 500, the last one, yeah, we like it. I really like it and I can do it, and you'll get to a point hopefully where you can see a question with a scale, whether it's a ratio in a map or whatever, and you'll be able to increase or decrease as you're going along. So this time, if the distance is 8.5 kilometres, okay, so this is the planned distance. If it's 8.5 kilometres, what's the real life distance? So we've taken the plan and we've increased the plan size by 8.5 times because we've gone from 1 to 8.5. So that's how much we've increased by. So because we've increased this side by 8.5, we're going to do exactly the same to this side. 8.5. Silly me. If anybody wants to use a calculator for that one, that's fine. But it's 4,250. There you go. Cracking way of doing that. That's okay, Chloe. You actually worked that out quite well, because if you had that without a calculator, you could just do 8 times 500 and then half times 500 and pop them together. Any thoughts on that? Yeah? Oh, well, I'm so pleased. So what we're going to do, if you've got pen and paper, it'd be really helpful. We've got some questions to work on. 6 questions altogether to work on. where we're going to use this method each time, just to try and see if you can do it yourself. And I'll do it on here, obviously, but if you want to have a go as well at home, we'll do it together. So let's look at the first question. So this is a scale drawing of a garden. Can you tell me the actual real life measurements? I haven't got a green pen, so I'm going to have a scale drawing of a pond instead. So we've got measurements of 2 centimetres by 2 centimetres, and the scale is for every 1 centimetre is equal to 2 metres. So this one is obviously much smaller than this. So this is going to be our plan size. This is going to be our real life size. Okay, so if we have plan measurements of 2 centimetres, how many metres is that in real life? We pop our 2 centimetres in. And it works either way. Even if you're told the real life measurement and you need to work out the scale measurement, you would pop in whichever side you know, and you do the same method, whichever way round it is. So let's have a look. So we've increased this side by 2, because 1 times 2 is 2. So we increase this side by 2 as well. Yeah? To give us 4. Sorry, metres. I apologise. 4 metres. Nearly, Chloe. We've got 4 metres on here. So if 1 centimetre is equal to 2 metres in real life, then 2 centimetres is going to be equal to 4 metres, because we've doubled it. Now, if we actually had something a bit harder here, let's have a look. See, I got that wrong. Assumed. Yeah, I can see where you're going with that. Yeah, you did make it a little bit more difficult, which is easy to do, to be honest, when you're facing a kind of simple question, if you like. So if this was actually, instead of 2 centimetres, what if this was 6 centimetres each? So this is our plan. If the measurement on each side was 6 centimetres each, we could then pop in what we know. So this was our scale here. So we know that on the plan, the length is 6 centimetres. So we look at the original scale and see by how much we've increased it by. We've increased it this time by 6 times as much, because we've gone from 1 to 6. So we've increased it by 6 times. So we're going to increase this side by 6 times too. Yeah? To give us 12. Well done. Perfect. Got that one. Did everybody follow that one? Any questions? And obviously, because you've got 2 dimensions, you would, if the measurements were different, you'd have to work it out twice. But this time, because it's a square, we started off nice and simple. We're just a square. They're both the same measurements. So in real life, we figured out that if the plan was 6 centimetres by 6 centimetres and the scale is 1 centimetre to 2 metres, then in real life, this is actually going to be 12 metres by 12 metres. Any questions? Just pop a yes or no in the box for me, because then I'll know if I can move on. That'd be fab. Thank you. Right, let's have a look at the next one. We've got a TV this time. So this is a scale drawing of a TV. So we have let me draw it for us. We'll have it on here. We have a TV. There we go. So this is a scale drawing of a TV. On the scale, this one measures 4 centimetres and the width measures 2 centimetres. The scale we have been given is for every 1 centimetre on the plan is equal to 25 centimetres in real life. We know that because this side is smaller, so we're going to presume that this is the plan side and this is the real life side. If you had a go, fab. So we've got 100 by 50. Let's work it through together. So let's add what we know. We know this is a plan, so we're going to put our plan measurements in. Let's do the length first. So for the length, we know that it's 4 centimetres. So we've increased the plan size by 4 times. So we're going to increase the real life size by 4 times 2. 25 times 4 will give us 100 centimetres. Okay? If you can write this out again each time if it's easier. But what we could do is the width or the height this time. So we know that the plan length for the height is 2 centimetres. So we use the original scale. We've increased the plan size by 2 because we've gone from 1 to 2, which is double the amount. So we're going to increase the real life size by 2 as well to give us 2 centimetres equals 50 centimetres in real life. So your TV is 1 by half a metre. So 4 centimetres is actually 100 centimetres in real life, and 2 centimetres is 50 centimetres in real life. How did that go for everybody? Tell me if I'm going too fast as well. I don't mind. Get it? Alessandra gets it. Love that. Yeah, Chloe's good. Nikki's good. Fidelia, you okay? Yeah. Okay. Let's look at the next one. So I've tried to include some different ways of asking the questions in here as well. Fidelia is very okay. That's brilliant. I like that. So I've took some questions from BKSB, so you might recognise some of them, but it would, it's helping you out if you're not sure, if you've not touched scale yet, you might come across some of these questions. So this one's on a scale drawing. A footpath around an allotment is 24 centimetres long. The scale on the drawing is 1 to 30. What is the actual length of the footpath? Now, this is one of those where I think when you see a question like this, there's no image, so it can be hard to picture. And because you've seen numbers like 24 and 30, you sort of think, oh gosh, this is a lot. But let's not panic, we're okay. So let's create an image. Sometimes I find it easier, if there's no image given in a question, I make one myself because I can find it easier to actually understand what we're doing. So we have a footpath around an allotment. Don't worry, I'm not going to draw an allotment. This could be our allotment today. There you go. And the path is 24 centimetres long, so that's going all the way around. The scale on the drawing is 1 to 30. So 1 to 30. So 1 is going to be on the plan to 30 in real life. So every 1 on the plan is equal to 30 in real life. Okay. What is the actual length of the footpath in centimetres? So let's apply what we know. We know that on a scale drawing, the footpath is 24 centimetres. So we put it on the side that we know. We might have been given the real life measurement. It doesn't matter. We could put the real life measurement and work the plan side. Either way, we're doing the same maths. So on the plan side, we put 24 in because that's what we know. We've increased then the plan from 1 to 24, so by 24 times. So we're going to do just the same on this side. We'd have to do 30 multiplied by 24. Does anybody have an answer for that one? Yeah, Nikki, that's not a problem at all. Yep, you've got no problems with that. That's fine. Chloe's got 720. Fabulous. So, because the scale was the length we were given of the allotment was 24 centimetres. So when we put 24 in, that was centimetres, and this would have been centimetres. So we need to, for the next question, it asks for it in metres as well. So we just need to convert our 720 centimetres into metres. How many centimetres in a metre? Well done, Josh. Thanks, Chloe. 100 centimetres in a metre. Thank you. So how do we get from 700 centimetres into metres? What would we need to do? Perfect. Well done, Chloe. We need to divide by 100. So 720 divided by 100. 2. If you, without a calculator, remember your decimal place should be there. So we move it 10, 100 times. That will give us 7.2 metres. Thanks, Fidelia. Thank you. So we had we started the question, didn't have an image on it. It had some numbers which weren't favourable. Are we okay with the answer, how we got there? So we finally had the answer in centimetres of 720. We then converted that into metres to give the answer in metres as well. Yeah. Perfect. Okay. Let's move on. Check that. Brill. Everyone's good? So map scale this time. Just move this forward so you can see it a bit better. Okay. Dan and Sam have been out walking using a map with a scale of 2 centimetres to 1 kilometre. The distance they have walked on the map is 14 centimetres. How far have they actually walked? I'm going to let you have a go at this one. See if you can apply what we've been using, the method that we have. I'll just set it up and then just let me know if you have an answer. Okay, so Dan and Sam have been out walking using a map with a scale of 2 centimetres to 1 kilometre. The distance they have walked on the map is 14 centimetres. How far have they actually walked? Nearly, Josh. Not quite, but I can kind of see how you've got to that answer. And this is where what you've done there, Josh, is quite often what some people do when I try and show this method. But I'll show you how I got there, and you can see what you did. I've got a couple of right. Let me show you this one. So the scale is on the plan. Everybody's done a similar thing. On the plan, the distance is 2 centimetres to 1 kilometre. Now they have walked 14 centimetres. Okay, so on the plan they have walked 14 centimetres. What we need to do with these arrows is work out by how many times we've increased or decreased the amount from the scale to the actual length on measurement. So what do we do to get from 2 to 14? What would we multiply 2 by to get to 14? 7. Exactly. Yeah. So this time we've multiplied this by 7 times. We've increased it 7-fold. To get from 2 to 14, we've increased the plan side by 7. So we're going to increase the real life side by 7 as well. So that would give us a real life distance of 7 kilometers. Does everybody see that one? I think what some people did was maybe multiplied that by 2 to get to 28, I think. And then this one was doubled. But what we need to do, and this is where this method takes a bit of practice, I'm not gonna lie. We need to look at this multiplication here is by how many times we've increased the amount. So we need to work out how we got from the plan to the actual distance on the plan. So we've increased it by 7 times this time. So we do exactly the same in the real life measurement. So 14 centimeters on the map is 7 kilometers in real life. Yeah, this is where it's going to take a bit of practice. I'll send you this recording afterwards as well. And I will try and get you some extra questions maybe to work on as well. But it might be worth, even if you've covered scale previously or you haven't covered scale yet, maybe look at scale quite soon after this so you can actually use this method and see if it helps with a lot more practice to get there. We've got a couple of questions left though, so we can have a look together. But we're just going to remember that when we're increasing, we're looking at by how many times have we increased the scale by, and that's this number here that we're going to use to multiply. Let's try another one. So a train journey is approximately 90 miles in real life. How many centimeters would this be on a map with a scale of 30 miles equals to 1 centimeter? Again, have a go. I'll set it up on here and then we'll go through it together. Anybody got any answers? Wonderful. Yep, so we've got a couple of answers there. Perfect. Right, everybody says 3, which is the correct answer. I'm just going to go through it just to make sure that we all understand how we got there. So if a train journey is approximately 90 miles in real life, how many centimeters would this be on a map with a scale of 30 miles to 1 centimeter? So this time we know the real life measurement and it's been switched a little bit, but we know that they travel 90 miles. So on this plan, every 1 centimetre is another 30 miles. Okay, if they travel 90 miles, I'll show you in a couple of different ways as well. That's another 30. That's another 30. So if we've gone from 30 miles to 90 miles, using the method, the arrow method, we're looking at increasing it by 3 times. So 30 up to 90 is an increase. Yeah, that's right. So 30 up to 90 is an increase of 3 times as much. So I don't know if you can see that, what I've just done up there actually. Every 1 centimetre is another 30 miles. So you've got 30 miles, 60 miles, 90 miles. So that's 1, 2, 3 centimetres. Now using the arrow method, we've gone from 30 to 90, so we've increased it by 3 times as many. So we do exactly the same this time, increase it by 3, which gives us an answer of 3 centimetres. Was everybody okay with that one? Yeah, that's right, Chloe. That's exactly right. Like I said, if you think about it like this, if every 1 centimetre is 30 miles, if you didn't use this scale method, you could, as long as obviously the amount isn't too much, you could just keep adding another 30. You know, if it was 120 miles, for example, that would be 4 centimetres because it's another 30 miles. So 30, 60, 90, 120 miles. So every 1 centimetre on this map, for example, is worth 30 miles. And that's exactly what that means. I've got one more question left on the tutorial. I've took this one directly from BKSB because I think it's quite a good one. It's a realistic one. Here is a plan of an exhibition layout inside an area. Let me start again. Here is a plan of an exhibition layout inside an arena. The scale is 2 meters to 1 centimeter. Okay, how long is the actual arena and how wide is the actual arena? So we've got an image here. It shows you the arena. It's got some stuff inside. It's got a model and stalls and a cafe. But we've got some measurements. So the length of the plan is 20 centimetres and the width is 10 centimetres. So again, I'll set it up on the screen if you guys want to have a go, and then you let me know what measurements you've got for the length and the width. Now, bearing in mind, oh no, just give you in metres and the scale's in metres, so we're okay. Just pop your answer in the chat box when you're ready. Alessandra's ready? Well done. It's not a race, by the way. Take your time. Well done, Josh. Like I said, this is level 1. If you're working at level 2, it doesn't hurt, particularly if you're taking on a new method. If I've just shown you this today and you quite like it and you think it's going to work for you, it doesn't hurt to do a lot of practice with these smaller numbers and the more simple sort of scale, like your 1 to 2 and the lower numbers. Just set yourself up a couple of measurements like this and then change them and see if you can use the scale. It'd be worth doing that, particularly before next week if we move on to level 2. We'll try and use the same method again, but we'll be looking at questions that are a bit more wordy, maybe have to convert in there as well. And the numbers, this is when at level 2 we start seeing nasty figures like 1 to 200,000 and things like that. But it's nothing we can't handle if we use this method. Just keep practicing with it with the smaller numbers until you feel a bit more confident with it. And then you can start taking on those level 2 questions using the same method as well. So we all got similar answers. I'll just go through it with anybody just in case they need me to. So this is our plan of the arena. It's a plan, so it's in centimetres. We've got 20 centimetres by 10 centimetres, so it's a nice rectangle. The scale was 2 metres to 1 centimetre. So that means for every 1 centimetre on the plan, it's worth 2 metres in real life. So we're given the plan measurements. So let's input what we know. This time we know the plan, and it's this side. So we'll do the length first. We know that that is 20 centimetres. So by how many have we increased the plan side by? We've increased it by 20 because 1 times 20 gets you to 20. Increase this side by the same amount. 2 times 20 will give you 40 metres. So for the length, we should have 40 metres. If we do the same with the width, again, if you can use the same one, and it's not too complicated to do, but if you need to write that scale out again each time, do whatever's easier for you. So this time we've got 10 centimetres. So we input the side that we know, 10 centimetres. We need to go from 1 to 10 this time. So we do that by multiplying 1 by 10. Do exactly the same this side. So we're multiplying by 10. So 2 metres times 10 will give us 20 metres. So you should have 40 metres for the length and 20 metres for the width, which kind of makes sense. I mean, when you look at the real life measurements, you can check yourself. This was in the scale, it's a rectangle, and even in the scale, this amount was half of this. So as long as you've got the same sort of scale in your real life measurements, so your width is half of your length, then you should be pretty much correct. So we should have a length of 40 and a width of 20 meters, sorry, in real life. Is everybody okay? Any questions at all? Fab. Thanks, Josh. I'm glad it's helped. Like I said, just set yourself up either on BKSP if you use scale, even if you access the level 1 module, just look at the learning pages on that, or maybe just have a go at the skill check and use this method at level 1 to practice this style that we've created today or used today. See how you fare with that, and then maybe if you're doing level 2, try and do the same then with level 2 as well. That was the last question on this one. So Chloe said, need to know all conversions off by heart for level 2, I think for the bigger numbers. Yes, I agree. I think it soon becomes clear when people start their learning, it doesn't matter which module you're working on, it's going to be very handy to know your multiplication table and your conversions, because conversions and different units of measurement can come up in lots of different types of questions. So those conversions will be really, really useful, because it would be a real shame if there is a question, for example, level 2 practice test, sample 1, where you have to work out a scale and then you're going from centimetres on the scale, but they want the answer in kilometres. So a lot of people give the correct answer in centimetres, but then they don't know how to, or they don't convert it into kilometres at the end. And that's a 1 mark question. So they've lost that mark, even though they've done all that maths and they've technically got the right answer. They've used the scale part of the question, they've got it right, but then they've not converted it at the end. So we can look at conversions as well in another tutorial if we need to. We'll do level 2 scale next week and maybe conversions the week after. So converting from centimetres to kilometres, the easiest way to do that is to go from centimetres to metres by 100, and then you go from metres to kilometres. You could do it in 2 steps if you needed to. we'll go through that on another tutorial if we need to as well.